Hello, we're going to start our course by reviewing the case study in Chapter 7 on card shuffling and dealing simulation. Now, we did cover Chapter 7 in week 15 of CS 121, so this will be a review. Some of the items reviewed in the case study include arrays, the random object, printf statement, classes, how to create them, how to instantiate objects from classes, how to have methods in classes, how to have constructors in classes, and the getters and the setters. Exceptions, we'll look at the final keyword. The static keyword is used in this case study. The concept of scope and even the modulus operator is used in this case study. So you see it's a good overview of what we covered in CS 121. This case study is made up of multiple classes. So when it is compiled, you will do what's called a multi-file compilation, which is easy to do within NetBeans. It will be in the same package. The three classes that are in this case study are card, and the card class is an object that represents exactly one playing card. Then there is the deck of cards object, which of course is an array of cards. In addition, there will be several methods in the deck of cards for shuffling and dealing. And then to test these classes, there will be deck of cards test, and this is the application that will have the main method in it. Here is the source code from the text, and we'll start by looking at the card class. The card class has two instance variables using the final keyword, and one to represent the face of the card and one to represent the suit of the card. The face and the suit will be strings such as ace or king. Now, some instance variables need to be modified. If an instant variable needs to be modified, you will not use the keyword final. But there are some instant variables that you do not want modified. So once a card is created, an instance of a card is created, and it's given a value for the face and the suit, such as ace of spades, it should not be modified later to queen of hearts. Here is the constructor for this class, and if you recall, the class name and the constructor are the same. When an instance of a card is being created, two parameter values, two arguments are sent, the card face and the card suit, and these are strings, ace, hearts, for example. The this keyword means this class, so it's saying look in this class for face, so it's actually representing this face, and assign to it what's sent in the parameter variable card face. And again, this dot suit will be storing card suit. And one other method that is in this class is the toString method. Now the toString method is actually implicitly written for all classes. So when you try to output an instance of a class within a string setting, there is an automatic format for outputting that string value representing this class. In this case, we want to overwrite the toString method so that whenever we're outputting within a string setting, meaning like you're concatenating with another string, for example, or you're using printf with a %s, indicating that the output will be a string. So when that happens, what's going to output will be whatever is in the value of face for that instance and whatever is in the value of suit for that instance. Now let's take a look at the deck of cards class, and it does use random number. And so if you recall, the secure random API needs to be imported. So prior to the class declaration, there is an import statement, and here is the hierarchy to import that library. Also, there is a named constant. If you recall, named constants will be all uppercase. And in this case, all deck of cards are 52. By creating a named constants here, this is easily modifiable if you have the source code. Going to write a Euchre program, for example. I'm not sure how many are in Euchre. I believe it's 9 through ACEs are in Euchre, and you can modify this number. Next, we have several more instance variables. One is an array. Do you recall that if you put these brackets after a class name or after a data type, you're going to be creating an array, and the name of the array will be deck. And it is a new, and here is the instance again. So we have card here and card here. And in this case, on the right-hand side of the statement, you will write how many elements will be in the array. In this case, it's 52 elements. Also recall, I'm getting ready to reference that array here, and recall that the first index is 0. So 52 elements will go from index 0 to index 52. Next, we have the constructor. Deck of cards is the name of the class. Deck of cards is the name of the constructor. This constructor will have 2 string arrays, one called faces, one called suits. Notice the difference in the declaration between the 2 arrays. So this right now is an array set to cards that haven't been instantiated, haven't been created yet. There are going to be cards in each element of this array. This will be a card, this will be a card, but nothing's been put into it yet. In this case, it is known ahead of time exactly what's going to be put into the array. So this is an array initialization where you declare an array. You don't need to indicate the size because it's going to be initialized in a comma separated list here in a set of curly braces. Same with suits. The rest of the constructor then is going to be a for loop that is creating the cards for each of these elements in the array. The for loops go from 0, so 0 correlates to that, to the length of the deck, and the length is 52, but notice the less than. So as long as it's between 0 and 51, we're going to increment counter and create a new card in each of these. So that's what it does. Deck at count, in this case, deck at 0, is equal to a new card. Notice here we have the modulus operator. Let's see how that modulus operator is going to work. So count is 0. 0 mod 13 is 0. So faces at 0 will be ace. So faces for cards will be ace. And likewise, now we have integer division. Since count is an integer, count is 0. 0 divided by 13 is 0. And suits at 0 is hearts. So that's going to give us the ace of hearts. We're done with that loop. It increments to 1. And now deck at 1, which will be here, will be a new card. And we're sending to the card constructor 1 mod 13. So 1 mod 13 is 1. So we will now have the deuce. And now we'll have 1 divided by 13. And this is integer division. So 1 divided by 13 is like 0.07. That's the total guesstimate. But since it's integer division, 0.07 is not integer. It will be 0. So we'll still have the hearts. So this is going to be the 2 of hearts. It's actually going to be the string though, but to save time, I'll write it like this. And it continues, and as you can see, what the modulus is going to do is 7, 8, go through all of these. Then when we get to 13 with the count down here, what will happen is 13 mod 13 is 0 again. So here we're going to have another ace, but 13 divided by 13 is 1. So now we'll be moving to the diamond. Okay, and then of course, then we'll have 14 next. And in 14 right there, we will have 14 mod 13. It's going to be a 1. And so, well, that's going to be deuce. And 14 divided by 13 is like 1.07 or something like that. But integer division brings it to 1. And we got diamonds again. And so we'll have the 2 of diamonds. And I think you can see how this is going to continue to populate this array with the deck of cards. Let's look at the shuffle method. So with the shuffle method, we have a variable called the current card. We're going to loop, it looks like 51 times, starting with the first card, and we'll be changing the first card. Well, here comes our random number. So some random number between 0 and 51 is created, and that is stored in second. Let's suppose, to keep it simple, since I've got data in here, that 14 is what was created for second. So second is 14, first is 0. Notice then what we're going to do is when we're shuffling, we're swapping the cards. Well, what I want to show you is, this may seem odd that even though I'm swapping 2 cards, I need 3 instructions. I need an extra variable of type card called temp. Let's suppose we don't do this. Let's just say, let's take the ace of hearts and put it here and take the 2 of diamonds and put it there. So that might look like something like deck at first equals deck at second equals deck at first. Let's execute deck at first is assigned the value of deck at second. Second is 14. What we're going to have here now is the 2 of diamonds. Then we'll go ahead and assume, since we're not using temp, that we're just going to say, well, deck at second equals deck at first. And you noticed deck at first already has the 2 of diamonds in it, so I've just lost the fact that we had an ace of diamonds. So this is why swap needs a temporary place to hold the data while the swap occurs. So what's going to happen is, let's stick this ace of hearts right here. This is, say, a card object in the heap, and the ace of hearts is in there. Ace of hearts is also there. Now we're going to take that 2 of diamonds that's in the 14, and we're going to assign it up here to deck at first, and first is 0. So the 2 of diamonds does come here. Next, we will take whatever's in temp, this is our temp, and assign it to deck at second. So deck at second will now become ace of hearts. Well, this is going to happen 52 times. A random number is going to be generated, and you're going to swap. So it simulates a shuffled deck. When that happens, you may want to deal a card. So this will be totally random now, not in order. And you just deal from the top of the deck, because the current card is just going to be 0. And you're going to return the current card, and then what are you going to do? You're going to increment it. So whenever there is a deal, it will return a card object. Finally, let's take a look at the deck of cards test. So the deck of cards test will create an instance of a deck of cards. Now notice in deck of cards that this will be the constructor that is declared, and you will have a deck of cards, not shuffled yet, from ace of hearts down to king of spades. Will be the last element in that array. Then we do shuffle it, so we will have a deck of cards that are shuffled. And this, in this example, they decided they're going to deal out all 52 cards. So what they're going to do is simply display the 52 cards. So let's say the 2 of diamonds is first, and the 5 of clubs is next, and the 4 of hearts is next. Let's get a nice one. The king of diamonds is in there. They're going to, and that is 1, 2, 3, 4. And then if I is 4, 4 mod 4 is 0, and it's going to do a print line, and it comes up, and I is 5, and it will continue to print out 4, and then a print line. So it looks like all this testing is doing is it will print out 13 lines of 4 random cards each. Now I think it'll be fun to actually write an actual card program. So let's see what we're going to do with this.